This video is still on power models, and we are doing sketching the graph based off of the equation for direct and inverse variation. So on this problem number 5, it's y equals 1 divided by x. First thing we look for is this direct or inverse. This is divided by x, so this is an inverse. That means that the graph will be split, so it's a discontinuous graph, so we will have to split it. That means I will have to pick up my pen. I will not be able to go through 0, 0. I will also have asymptotes. That means that it's going to curve along the x and the y axis. Then we look to see if our k value is positive or negative. So we have a 1 over x, so this is just k is greater than 0. That means that it will go through quadrant 1. And then we look at our exponent. Our exponent on this one is 1 over, so it's x to the first. So our exponent is 1. That is an odd number. It means we'll have opposite quadrants. So opposite of quadrant 1 would be quadrant 3. Now, as I stated in a previous video, that even though this is an exponent of 1, this is not linear, so this will still have a curve. The only one that does not have a curve is when it is a linear equation, a direct variation equation that is linear. Not quadratic or cubic, but linear. When it's a direct variation with an exponent of 1. That is the only one that does not curve. So on this problem, our k value is 1. That means for inverse, if it's bigger than 1, the curve is further from the origin. So this curve is actually going to be fairly close to the origin, but it cannot actually touch it. So again, we want to curve it along the x and y axis because it cannot go through the y axis and it cannot go through the x axis. So we want to start in quadrant 1. In order to do this, we place it along the y axis, coming down, and then we curve it to go along the x axis. But we have to curve it to the right because if we go to the left, it would cross, and we can't have that. Then we're going to do the same thing in the opposite quadrant, quadrant 3. We're going to curve it along the x and the y axis in quadrant 3. And we just make sure that the graphs never touch the x and y axis because those are what we call the asymptotes. So in this case, as x approaches negative infinity, so as it's going left, this graph keeps going closer and closer and closer and closer to that y value of 0, which is the x-axis. So it never actually touches it. So as x approaches negative infinity, y approaches 0. As x approaches positive infinity, so as it goes to the right, this graph also keeps going down and down and down and down, but never crosses the x-axis, so it's approaching the value of 0. That's what we call end behavior. On this next example, we again have an inverse variation because it's 1 over x squared. So again, that means it's a split graph. We have a k value of just 1, so it's greater than 0. Means we will have quadrant 1. And then our exponent is 2, which is an even exponent, which means we'll have side by side. So beside quadrant 1 would be quadrant 2. So we know that it's going to be split as inverse. It's split, it has asymptotes. Our value is 1, so it's going to be close to the origin. It's not going to be further away. So we're going to, in quadrant 1, we're going to go along the x and y axis. We're going to curve it away because we can't actually touch it. And then we have to go into the side-by-side quadrant, which is quadrant 2. So we're going to do the same thing and go along the x and y axis. About the same amount of curve at the origin. If it's not exact, I mean, this is just a sketch. So you do want to see that, you do want to try and get your curves to be about the same. But since it is a sketch, we just want to make sure that these do not cross the x and y axis. On this last example, we again have an inverse variation. So it is split. Will not go through 0, 0. It will curve along the axes. Our k value is negative 1, so we have k is less than 0, which means it has to go through quadrant 4. So it's going to start in quadrant 4. And then we look at our exponent. Again, our exponent is 1, so that's an odd exponent. That means opposite quadrants. So opposite of quadrant 4 would be quadrant 2. And our value is 1. The k value is technically -1, but the absolute value of that is just 1. So it's normal. That means it's going to be curved close to the origin again. So we're going to have quadrant 4 is where we're going to start. We want to curve it along the x and y axis and have it close to the origin. And then we're going to do the same thing in quadrant 2, which is the opposite of quadrant 4. So curve it along the x and y axis. So on this one, as x approaches negative infinity, so as it goes to the left, our value is still approaching 0. Our y value is still approaching 0. And as x approaches positive infinity, so positive infinity is to the right, the y value is also still approaching 0. So even though these are reflected over the x-axis, even though they are one's positive, one's negative, the end behavior remains the same because as the x's go left, it's still getting closer and closer to 0. And as the x's go right, it's still also getting closer and closer to 0.